Okay, so we're going to be analyzing Michael Fowler's experiment to prove that the one mass did indeed went twice as fast than the four mass. And we're going to be doing a good analysis. What Draftscience did was a poor analysis, because first of all, he started comparing both velocities right after the masses were dropped. Now, obviously, they were still accelerating towards their peak velocities. And what we want to know their peak velocities right before impact, obviously. So obviously you're going to get wrong answers. Okay, Draftscience, you fucking idiot. So let's take a look at the analysis. So this is a four mass right before impact, right before it's going to compress the spring. And over here at the right bottom corner, you can see the timings. And I can click and play with the frame rates. So let's pick a round number. Let's say 28. At 28 over here. I would pick it, and then we're going to go back, let's say 2 milliseconds before. So at 26. There we go, 26. Can you see it? 26. Let's take a print screen. There we go. And then again, 2 milliseconds later at 28. So the difference in time will always be 2 milliseconds. 28. We're going to 28. There we go. 28. So this is 1 frame per millisecond, which is nice. Print screen. All right, so this is trial 1. We put that in the left corner here. And now we're going to take a look at trial 2. This is trial 1. Now trial 2, right before collision. Let's take a look what timings we can use. Let's take this timing, 105. And then we're going to go back 2 milliseconds to 103. 103. Like this. Print screen. Over here. And now again, 2 milliseconds later, to 105. Oh, hey, yes, there we go. Print screen. Okay. All right, so these are the 2 trials for mass 4. Now mass 1 going twice as fast. So right before impact, let's take a look. Let's use 130.20. Now we're gonna go back 2 milliseconds to 128.20. See 128.20. There we go. Print screen. Okay. Let's place it down here. And then 2 milliseconds later to 130.20. Right. And print screen. Good. Now, second trial. Right before impact. Let's pick 201.20. So we have to go to 159.20. There we go. Print screen. And now 201.20, 2 milliseconds later. this. And now we need a ruler. So this is going to be my ruler. Let's take a print screen of this one. Let's take 6 centimeters. Place it over here. We have to rotate it. And now we have to make it smaller to fit it. So what I'm going to do is I'm going to pick a reference line, and it's going to be the 2 centimeter mark. So over here. And I'm going to make sure that this digital ruler will be the same size as this ruler. So let's take a look. A little bit smaller. Almost. Almost. Yeah, I think yeah, almost. Yeah, there we go. They fit. So right next to so it aligns with the 2 centimeter mark. Now I'm gonna copy paste this in every print screen. Like this. This is going to take a while. Bear with me. It will be worth it. There you go. Copy. Now one mass down here. So right at the 2 centimeter mark. Like this. I think that's it. Oh, one more. Over here. All right, so now let's take a look. This is the 4 mass. So its initial height is over here. And then 2 milliseconds later, it's over here. I'm gonna pick the low side of this pen. Next trial. So it seems to be over here. And then over here. Right, now for the 1 mass. Let's take a look. Seems to be over here. And then over here. Next. Hold on. This is a little bit vague, but roughly over here. And then over here. Yep. All right, so now let's take a look at the amount of displacement. First, the 4 mass. So we have, it seems to be 1.9, 1.85. 1.85. Over here we have 1.8. 0.8. On. So minus 0.8. Minus 0.8 centimeters, which is 0.05, right? So that's the difference, 1.05. And now the next trial, the initial height is 1.56, 1.65. 1.65 minus, over here we have 0.6, clearly 0.6. So we have the same result. So 0.6, 1.65 minus 0.6 equals 1. 0.05. Huh? So these are the same displacements, 1.05, 1.05. Now for the one mass, the initial height seems to be 2.8. 2.8 minus, let's see, what seems to be, hold on, I think I got it wrong over here. It's actually a little bit higher. Seems to be over here. 0.6. 0.6. So just hold on. 0.6. So what is that? 2.2. 2.2. So we have 2.2 over here. And over here we have 1.05. So 1.05 times 2 is 2.01. So we have 2.01 versus 2.2. So it's pretty much twice as much. Okay, pretty much twice as much, almost exactly twice as much. 1.05 versus 2.2. Now in the next example, over here, we have 2.8. 2.8 minus which seems to be 0.6 again, 0.65. It's around 0.6 again. So again, it's the difference of 2.2. 2.2 again. And this number is the same, 1.05 and 2.2. So we have a ratio, an average ratio of, let me write it a little bigger, 1.05 versus 2.2. Come on. What happened? One big numbers. Jesus Christ. 72, please. 2.2. Yes. Now in red. Or whatever. So we have 1.05 versus 2.2. 2 times 1.05 is 2.1. So 2.1, but it's actually 2.2. So really close to twice the speed. So draft science, you're a fucking asshole. You're a fucking idiot. Okay? It went twice as fast. Not 3 times or 4 times as you claim it to be. 2 times as fast. Right? Deal with this. Of course you won't. Because you're a coward.